Okay, so if there aren't any questions, that's your answers to the sometimes, always, never. Here are the quadrilateral types. So it's a list of quadrilateral types. I didn't get an answer for 11, did you? We know something about one of the diagonals, and we know something about one of the pairs of sides, but that doesn't really tell us anything. Would you agree? You can't say anything else. But you don't know that. But you don't know that. All you know is this congruent information. I think they meant it to be a typo. I think they meant it to say AE and EC. So the diagonals were bisected each other. Do you know something else, Julian?
Yeah.
Do you? Oh. Oh, okay. Well, then that makes a big deal, doesn't it? All right, so I just picked the wrong thing. Sorry about that. All right, so let me look at your things and let's make that decision. Can I look at yours real quick? Okay. So, all right, this is not, we'll just kind of delete this one because this obviously is a totally different thing. So, oh, I saved it. That was the wrong thing to do. Delete. Okay, so let's try again. All right, so if we look at number 8, yes, it's a parallelogram. 9, yes, it's a parallelogram. 10 is no, it's not a parallelogram. 11 is no, it's not a parallelogram. 12, no. 13, yes. Is there anything I can go over and explain? Although I guess it's really the same question, it's the same pictures, right? It just was, hang on. Oh, there we go. It was the same pictures. It was not just not classified. It was just, is it a parallelogram, yes or no? Is that just the directions were different? The pictures were the same, right? Okay, so rather than list type of quadrilateral is it a parallelogram? Okay, that looks better. So this one is yes. Remember how we talked about if the same pair, one pair of sides is both parallel and congruent, that it's not a trapezoid, because a trapezoid is over here at number 10. Didn't we talk about that? Number 10 is a trapezoid, but number 8 is actually a parallelogram. So that is one of the ways to prove parallelogram. That's the odd, the unusual one that we talked about last class. This one is yes, because it's the definition. Both pairs of opposite sides are parallel. This is not a parallelogram. Isn't it actually a trapezoid? Right? One pair. Actually, it's an isosceles trapezoid. Figure's not drawn to scale, obviously. Okay? But if you're looking at just what's marked, that's true. The 11 one is the weird one. Do you guys have that information? BE, again, so you have this and you have this. Definitely not enough information to say parallelogram. Okay? So this will be a no. And then 12 is a kite. It's not a parallelogram. And then 13 is actually a rhombus, isn't it? But yes, it's a parallelogram, specifically a rhombus. But that should, thank you for pointing out I had the wrong directions there. Okay? Okay so far? All right. I don't have access to one of the drives on our computer right now. I've emailed the technician, but so I don't have the area answers right now. But I graded 17 on the homework on the area page, so I thought we could at least do that one together. So if you'll look at the area page from your homework, we can look at that one, okay? And if you look at this particular question, not very many of us got 6s, so if you got a 6, that was a good thing. What do I need to do? This was kind of like a question on your quiz. What do I need to do? What do you always do when you have a polygon and you're trying to find its area? Divide it into triangles. And how do I do that? Draw in the what? The radiuses. So I'm going to continue to draw in the other 2 radiuses. Okay, pretend like that went to the corner. There we go. And I have that they're all 8. Would you agree? All those radiuses are 8? Because I'm given that one of them is 8. So I'm just going to look at one of the triangles. And I'm going to kind of draw it separate. I know that the area of the whole thing is 3 of these things, right? They're all congruent. So I have 3 1/2 base times heights. You with me so far? There's 3 of those triangles. We've got to find the area of one of them. Well, what do I know about it? I know that these 2 sides are both 8 because those are the radiuses, the spokes of the big triangle. Would you agree with that part? Okay. That doesn't help me because that's neither the height nor the base of the triangle. So what do I need to add to the picture? angles, and don't I need to draw this guy in? Don't I need to find the height? Okay, so what angles? How do I find the angle? I know that the big angle in the here is going to be what? Which is 120, right? So 360 divided by 3, so I know that that big angle is 120. When I divide it into 2, what do I have? 60. So I know that this is a 60-degree angle, okay? So I have a 30, 60, 90 triangle. Good. All right, well, what side do I know in my 30, 60, 90 triangle? I know the hypotenuse. And I always want to go and I want to find the short side. So how do I go from the hypotenuse to the short side? Divide by 2. So 8 divided by 2 is 4. So I know that this angle across from the 30 degrees is a 4. And isn't that the height of the triangle? So I'll put that in here for the base times the height. So now I need to find the base. Well, in a 30, 60, 90 triangle, what's the length of the long side, the long leg? Well, it's the short leg times radical 3, right? I need to find the entire base, this entire thing, so I'm going to multiply that by 2. So the entire base is just 8 radical 3. So 8 radical 3 goes here. So I have 3 of those triangles, 1/2 base times height. And when I multiply those all together, I get 48 radical 3. A couple of you left your answer in that form, which is fine. But then the decimal approximation is about 83.14. That help, Addie? Better? Just had to divide it up into triangles. And the triangles you're dividing it up into go from the center to the corner of the figure. Okay? And then we know that there are 3 of them. That's why the 3 is there. And then we just have 1/2 base times height. You've got to know your 30, 60, 90 triangles in order to do it. Okay, you just got to know those properties. Marvin, question?
Yeah, no, it seems like we not like suppose the that triangle that you just highlighted should be the same length as the other 2.
It is. It is. It's just not drawn to scale maybe because the figure, when it's drawn on the smartboard, the pixelation kind of like squeezes it together. But it is actually, I'll just draw it for you. Maybe that'll prove it. This is a radius, this is a radius, this is a radius. They're all 8. Therefore, they're all isosceles triangles. So they are all congruent. I know it looks odd. Hey, I'm teaching. What's up? All right. So are there any other questions about polygons? Anything on the homework or area you weren't sure of how to find it? Anything like that on the area of quads? Yeah. 15? Sure. Let's look at 15. Okay. So 15, was that a trapezoid, a kite? What was 15? It was a kite. You mind if I borrow it to copy it? Okay. So we have this information. We were told that this whole thing was 9, this was 6, and this was 6. Okay. Well, the way that the example that we did in class, we divided this kite into a top triangle and a bottom triangle, right? But there's another way to divide this up, actually. If you look, isn't this one triangle over here? And don't I have the base and the height already? Do you see that? So this one would just simply be 2 of those triangles. And it's 1/2 base times height. What's the base of that triangle? Actually, the whole thing is 9. That's the base of the whole thing. Okay? So it's actually 9. And then the height is just 6. It's just turned sideways. Okay? So that would be the formula to find the area of that kite. Okay. Any other questions on the homework? The area of quadrilaterals or polygons for that matter. Yes, ma'am.
Like, I saw that find the area of an isosceles trapezoid. Is it the same for like a different type of trapezoid?
Any trapezoid is 1/2 height base 1 plus base 2. It's just a general trapezoid formula. But sometimes you can divide it up into like triangles and rectangles, and that's okay too, and just add them together. Either way works. Yes?
By the way, I think I saw like a formula for a kite. Like
There is a formula for a kite, and there's a formula for the rhombus, but I'm not teaching those to you.
I thought those are really hard. I think it can't be.
Right. Yeah, I'm not. And like the rhombus is like diagonal 1, diagonal 2, and just do it the same way every time. Divide it into triangles, just easier. Okay, any other questions on area? You sure? Okay, now go ahead and take your notes out. We are going to look at a couple of things. I don't want you to write this whole thing down, please don't, but we're going to talk about some things. Today is going to be proving parallelogram and other quads. So we're going to be looking at how do I prove something is a parallelogram? How do I prove something is a rectangle? How do I prove something is a rhombus? Okay, that kind of thing. But mostly, how do I prove a parallelogram? And we'll look at some other ones specifically. Okay? But again, don't write what you see down here. We're just going to kind of highlight a couple of things. I'll tell you what's going to be important to copy down, okay? Slide here. If you look at this slide, there's one up there that is kind of the unusual one of how can I say that something is a parallelogram. The first one, definition of parallelogram. If I'm trying to say that something is a parallelogram, can't I just say that opposite sides are parallel? First one. That's the definition, right? So that's something I can do. I could also say that if both pairs of opposite sides are congruent, it's a parallelogram. Okay? This is an interesting one. If you look at this third one here, okay, that an angle is supplementary to both of its consecutive angles. What does that mean? Well, consecutive means that they're the ones that are adjacent with the parallel lines, right? Consecutive interiors, so to speak. So if I can say that the 105 and the 75 are supplementary, and the 75 and the 105 are supplementary, isn't that a parallelogram? Well, look at this. If these two are supplementary, doesn't that prove that that's parallel? And if the other two are supplementary, doesn't that prove the other two are parallel? Right? So really, I'm just proving parallel again. It's a different way to do it. Notice something for me. If I notice that the 75s are congruent, that's really the next theorem. I can prove it's a parallelogram if both pairs of opposite angles are parallel. Okay? I'm sorry, not parallel. Angles are congruent, aren't they? Both pairs of opposite angles are congruent. That's kind of new. I'm not sure we added that. On your sheet from last class where I had you draw all the different quadrilaterals and I had you add number 6, the kite, underneath parallelograms, and I know there's probably not an extra blank for it, but can you add that one? I don't think we listed that as a property, did we? Double check me, but I don't think we did. I did in my first block class, but I don't think we did it in 6th block. So look at that sheet, okay? The one that has the, there you go, Maddie, can I borrow yours since you have it? The one that looks just like this, okay, where you had to add kite at the bottom. We did this yesterday, our last class. If you will do me a favor, somewhere on section 4, just add that. I'm not sure where you're going to put it because there's not a whole lot of room, but both pairs of opposite angles are going to be congruent. Let's see, I'm going to trip and fall on your stuff, honey. Are congruent. So you want to add that somewhere in there, okay? Good. We already have in there that the diagonals bisect each other, right? So we should have that listed. But the last one is one that was on our homework, and it's one that we talked about last class as well. But if I can just show that one pair of opposite sides is both parallel and congruent, then it's also a parallelogram. So just kind of a recap of how do I prove something is a parallelogram. And there's really lots of ways, isn't there? Okay, so lots of different methods, things I could choose from to go that route. Any questions so far? It's pretty straightforward. All right, so we're going to kind of use these rules, these things, and I want you to kind of, these are some examples you should probably copy into your notes, okay? I'm not sure why I just copied them from the book, so they're weird numbers, so we'll just renumber them 1 and 2, okay? And let's figure out how I would solve for x here. What would I do in order to prove that it's a parallelogram? What must x be if it were to be a parallelogram? So I want you to look at each of those examples. Both pairs of opposite sides are parallel. Am I using the diagonals bisect each other? Am I using opposite angles are congruent? What am I going to be using? Okay? So copy them both into your notes. and we'll come up with an equation to solve for x, and we'll make a decision as to which property or which theorem am I really using. So I'm going to pause the recording for a second while you guys copy it down, okay? So in the first problem, I'm sure you can come up with the equation very quickly. Okay? What is the equation for number 1? 3x is equal to 4x minus 5. Okay? Nothing that we didn't expect. What I'm going to ask you is to justify why that's true. Why is that true? Which one of these theorems proves it? So look over your theorem list and tell me why. Amira? The diagonals bisect each other. Very good. So I want you to write that. The diagonals bisect each other. Therefore, I know that that's true. So anytime I ask you to justify, this is what I'm looking for. Okay? I want you to justify with what is the reason that I can say these things. Question?
Question. How do you know that 3x is 4x minus 5 if we don't have math only 130?
If it's a parallelogram, then the diagonals must bisect each other. Right? Okay. So if we solve this very quickly, x is equal to 5, right? Nothing too difficult. How about number 2? What's the equation first? Let's start there. What do you think, Daniela? What's the equation? Exactly. It's just kind of what you think it's going to be, right? Now, what's the justification? Why can I set those two things equal to each other? Let's look at our list. Why is that true? Julian? Nope. Try again. Lucia? Nope. Look at what's given to us. What's marked? What's marked in number 2? I've marked one pair of parallel sides. That's what the arrows mean. Are they hard to see, the arrows? So I know that this pair of sides is that AD and BC are parallel. Well, the same AD and DC, or AD and BC are also marked with the 3x plus 1 and 6x minus 4. So if it's going to be a parallelogram, look back again at our list. Which one of these is the reason? The same pair is marked both parallel, and we could set them equal to each other so that they would be congruent. So which one of these theorems is it? Jason? The last one. Okay? That one same pair of sides is parallel, and that same pair of sides we're going to say has to be congruent. That's why it's a parallelogram. So we're going to say one pair of opposite sides is both parallel and congruent. Okay? So that would be the justification of why I can write the equation that I am. So again, I'm going to be asking you to do that. Justify. So pick from the list. What is happening? This list is in your textbook, by the way. Okay, I just copied it right out of it, so you can look for it there. Okay? All right, so if we solve here, we'll subtract 3x. We'll add 4. X is equal to 2.5. Did you guys get that? Oh, no. I didn't solve it right. What did I do wrong? Yeah, it should be a 3x, right? Okay. So x is equal to 5/3 or 1 2/3. Either way you want to say it. 1.6 repeating. Okay. The justification is the key part. I think anyone can do the equation. If it looks like congruent, it probably is. But it's the justifying that's the hard part. Okay. If I know it's a parallelogram, let's just do one at a time here. Okay. I know that it's a parallelogram. I'm telling you it's a parallelogram. What are the coordinates of B so that the figure is a parallelogram? What must those coordinates be? I have seen this on the SOL, so please write it down. Okay? Please copy this one into your notes. Maybe I'll start off with a little bit easier. Maybe if I make this a 4 rather than the letter C, you might find it a little bit easier to solve. So let's start off that way. Okay? How can I find the coordinates of that parallelogram? Or at least of point B? Well, we know some stuff about a parallelogram. What's true about the sides in a parallelogram? Opposite sides are what? They're parallel, first of all. And do I know how to find parallel on a coordinate plane? What formula do I use to show that something's parallel? Slope. So could I find the slopes of the opposite sides and go from there? Sure. Is there a quicker way maybe to solve it? To find it? Anybody have an idea? Opposite sides are also congruent, aren't they? So I know that the length from D to C must be the same length as A to B. And those are horizontal lines. Could I just count? All right. So what coordinate do I know for point B? I actually know them both. What's 3? The X or the Y? Very good. I know that this has to be 3 because these coordinates, if they're horizontal, which they are, in this case, need to be the same. We'll go up as far, same as far, if it's horizontal, right? Okay, so that's got to be a 3. I agree. What about the X coordinate? Is it 2? No. Is it 4? It's 6. Where'd 6 come from? I agree. Deshay? Very good. I know that the length is 4 down here. So if I'm starting at 2, I have to add 4 more. Perfect. So that's a 6. So the coordinate 6, 3 will give me the coordinate B. Awesome. Now, the way I've seen it on the SOL is that there are no numbers, just letters. So let's take this idea and let's figure out, I'm going to make this a letter C. Okay? Not a number. And I want us to write what the coordinates of B are here. We got to think about this in terms of what did we add, what stayed the same. Look at the previous problem and make that decision. Okay? So what are the coordinates of B? You're going to have to write it in letter form, just like the ones are given to you. We have A, B, and C. So your coordinates for point B will have the letters A, B, and C there. Which coordinate is just the same as one of the given ones? I don't have a D. Well, I have point D, but it's 0, 0. Look at what I did in the previous problem. The yellow highlighted dots. Aren't they the same? So aren't those Y coordinates up at the second part the same? So what is this Y coordinate of B? Point B. B. Because they're the same. Would you agree? We went up as far. We went up B. The Y coordinate's the same. India. It'll be on School Fusion, so if you haven't copied it yet, because we've already almost done with the problem, you can print it off at home. What are the X coordinates? Very good. It's A plus C. So this is the coordinates of point B in terms of the letters. Remember what we did. We added the X coordinates to get as far right as I needed to go. And we went up the same amount, so the B's stayed the same. Touché? If I had left C in the problem, it would be 2 plus C. That's exactly right. Very good. Okay? That is the answer. Yeah. Sometimes, and that's the uncomfortable thing, if it's given to you in letter form, your answer is going to be in letter form. Okay? We're not looking for like a number 2 or 7 or something like that. But over here we had all numbers, so our numbers were expected in the answer. Okay? All right. So let's go ahead and look at these 4 problems. You don't have to copy these into your notes. Let's just decide for ourselves. I'll go ahead and pause the recording while you guys talk about it in your groups. Which one is which? Okay? Do we have a parallelogram? Do I have a rhombus, a quadrilateral? What kind? Just a regular old quadrilateral? That's all I know. Do I have a kite, a trapezoid? What do I have here? Okay? And so I'm going to have you guys come up and write the name. The most precise name. So if it's more than just a regular old parallelogram, like I know it's a rectangle, say rectangle. If I know it's a square, say square. The most precise name. So go ahead and think about it. I'm going to pause it, and you guys talk about it in your groups. Tell me what you think. I disagree with one. So I want you to talk in your groups and figure out which one is maybe not correct. The other 3 are fine. Decide which one you disagree with. What you think? You disagree with the square? Why? What additional information would I need to make sure that it was definitely a square? It sure looks like a square, but the angles. I would have to have right angles. There's something else I could have had. If I didn't have the right angles, I could have had something else, and it would definitely have been a square. What else is a defining characteristic of a square, or a rectangle for that matter? Either the right angles or, think of the diagonals. The diagonals would have to be congruent. So I'd have to have some extra piece of information to say that the angles sure look right, though, don't they? They look like 90-degree angles. I get that. But they're not marked that way, so we can't assume it. So we would have to have either the right angles, or we would have to have that those diagonals would all be congruent. Does that make sense? Then it would be a square. Definitely agree. But for now, what is it actually? It's a rhombus. That's all I really know. Okay? Good. All right. Don't copy this down either, but I want you to read it. Okay? Let's look at this problem. I'd like for us to go ahead, and I want each table to get a whiteboard. You can get a small one up here, a dry erase marker. And I want us to look at this particular problem. So come up and get a dry erase marker and a board. We're going to do it on the non-grid side, if you would. And we're going to use that grid side in a few minutes. So we're actually going to use both sides of that just momentarily. But for now, just get the non-grid side and a markings. Okay, so this is actually an application of quadrilaterals that anybody who does plot work, who does site work, civil engineers, people who do any kind of designing of land, when we're talking about a rectangular object, builders use properties of quadrilaterals to kind of square up corners. And we know that in a rectangle, the diagonals are what? What are the diagonals in a rectangle? They're congruent. So we know if we have 2 strings, for that matter, that are exactly the same length, we could create a rectangular shape. We could kind of square up the corners, they call it. Make 90-degree angles. Yes. 90-degree angles. Okay? So these are some examples, okay? So can I adapt this method? So we're looking at the very, very bottom here. Can I adapt this method to stake off an exact square play area? So tell me what we would do differently, or in addition to, if that makes sense, to this method. So I don't care about a rectangle necessarily. I want it to be exactly a square. So how would I do that? What would I have to do differently to ensure that it was definitely a square? What do you think? Nobody has an idea? Would the diagonals have to be congruent if it was a square? Okay, so at least I'd have to start with that. Would you agree? So how could I take my strings, and where would I put the people in order for it to definitely be a square? How could I guarantee that? Yes. Well, the angles are going to be 90 degrees no matter what. I agree, because if you have the congruent diagonals, they're automatically 90 degrees. So yes, that is going to be true. That happens. That's kind of a default, believe it or not. Hang on. Reese, did you have something to add? Okay, the diagonals would bisect each other. Absolutely. And that actually happens in any parallelogram. So that's going to happen almost as a default as well. Okay, so good. These are all things that are going to happen. But let's be specific about a square. What additional information do I need for it to be a square? Mm-hmm. That's what we're looking for, okay? So all things are true. I agree. These diagonals would have to be congruent, so I know all of that would be true. They would bisect each other. We would have 90-degree angles, which means if I was drawing this in, we're going to have 90-degree angles as a default because the diagonals are congruent. It's a rectangle. But to guarantee a square, I would have to say that this length is the same as this length. Would you agree? The people have to be certain for certain distances apart. That would guarantee a square. Awesome. Okay, if you would, go ahead and turn over your drawing board. And you guys might want to get your own. Since you're so far apart on this table, go ahead and get your own dry erase board, marker, and whatever. So everybody should have it on the coordinate method side. And I want us to draw this particular quadrilateral. It has the coordinates 1, 4, 3, 5, 6, 1, and 4, 0. And I want us to prove what kind of quadrilateral it is. Okay? So I'm going to turn one light on so you can see what you're drawing. And I want us to figure out, so go ahead and draw it on your whiteboard, and I want us to prove what kind of quadrilateral it is. How would I do it? When you graph it, it should look something. You should have some kind of idea where to start. Does it look like a kite? Does it look like a trapezoid? What does it look like to you? Parallelogram? Does anyone think it could be a rectangle? Hard to say. If we're trying to prove one thing it is, we have to prove something specific. So if I'm trying to show parallelogram, I could show what? If I'm trying to prove that it's a parallelogram, if I go ahead and graph this, how would I prove it's a parallelogram? Think back to what we did first thing this morning. Anyone think it could be a rectangle? Maybe. If I can prove it's a rectangle, isn't it automatically a parallelogram too? Okay, so maybe we should start with trying to show it's a rectangle first. There's two ways I can show rectangle. Give me one of the ways. Give me one characteristic about rectangles that's true about rectangles only. 90-degree angles. How would I prove that using the coordinate methods? I know you know. Slope. Very good. So I'm going to find the slope of all four lines, all four sides. I want you guys to do this, okay? So you can do it right on your whiteboard. That's fine. I want us to find the slope of AB. I want us to find the slope of BC. I want to find the slope of CD and the slope of AD. So all four slopes. How do I do that? Can I just count? What am I counting for? Rise over run. So let's look at AB. The slope of AB is up 1, right 2. So isn't that the slope is 1/2? Yes? All right, the slope of BC. I'm going to go up 1, 2, 3, 4, and left 1, 2, 3. So up 4, left 3. You with me so far? Okay. CD, up 1, right 2, and AD. 1, 2, 3, 4, 1, 2, 3. So I have found the slopes of all the sides. If I was trying to show right angles, what would I be looking for? Perpendicular lines, so I'd be looking for opposite reciprocals, wouldn't I? for adjacent sides. Are these two opposite reciprocals? Well, opposite, one's positive, one's negative. But are they reciprocals of one another? No. So is it a rectangle? Definitely not. So I know I've ruled rectangle out. Now what is true about it? These two are parallel, and these two are parallel because they have the same slope. Would you agree? So when I have both pairs of opposite sides parallel, what is it? It's a parallelogram. And the method that I used was the slope, and I proved that both pairs of opposite sides are parallel. True? All right, erase your board. Let's try one more. Okay? Let's figure out what this thing is. So erase your board. Go ahead and give your pen to somebody else at your table so you're not doing all the work. Pass the pen. Okay? Come on, Ryan. You can draw. I know you can. Let's graph these 4 points. Negative 2, 4, 2, 6, 6, 4, and 2, negative 3. What kind of a quadrilateral does this look like? You're going to have to do this in your homework. You're going to have a couple that you're going to need to graph and figure out what kind of quadrilateral it is. Okay? So let's do that. Let's graph it first and make a decision. What does it look like to you? Did I draw that right? No. Let's make sure I graphed it right. All right. What does that look like to you? Looks like a kite. All right. How do I prove? What's the definition of a kite? We know that the diagonals are perpendicular, right? Is that enough to prove it's a kite? Is there any other quadrilateral where the diagonals are perpendicular? Yeah, I know that's true in a rhombus and a square. So would that be enough? No. What do I need to show here in order to prove that it's definitely a kite? What do you think, Andrea? Or what? I'm going to have to use the distance formula, aren't I? I need to prove, I heard moans, I love it, that JK is congruent to KL. Okay, I got to find that. So we're going to find the length of JK. The length of JK is the square root of, remember this? The distance between the x's, negative 2 minus 2 quantity squared, plus the difference of the y's, 4 minus 6 quantity squared. Well, that's negative 4 squared, and that's negative 2 squared. 16 and 4, that's just the square root of 20. We could reduce it, whatever. So this is the square root of 20. If it's going to be a kite, what must the length of KL be? Square root of 20, okay? Because we're running out of time, I'm just going to move on, okay? But we would have to show that. What else? Is that enough to show just those two are going to be congruent? Wouldn't I also have to find these two lengths as well? Okay? So on your homework, you're going to have to do a couple of these where you're going to have to look and decide, first graph it, and say, okay, I think it's a kite. Let me go ahead and look at that and figure out what I would need to do to prove that. Oh, wait a minute. I think it might be a parallelogram. Look what I have to do to prove that. Okay? So let me go ahead and give you what your homework is. It's going to be on a couple of different pages. Go ahead and erase your whiteboards. Go ahead and put them back up here for me if you would kindly do that. Oops. So it looks like a lot, but it's really not that many. It's just kind of scattered about in the problems, okay? Okay, I'll do these two. All right, so this is going to be your homework. Again, it's not as many problems as it looks like. It's really only like 8 problems total. It just happens to be across 3 different pages. So you can take a picture of that, or you can copy it down. I'll probably, most likely, I'll text it to you as well, but it'll be due on Thursday. Okay? All right.